This is review sheet 3.1 to 3.3 for chapter 3. The first three questions are going to be multiple choice, which are similar to ACT questions I've seen while teaching my ACT course. In triangle MPX, which angle is included between PM and XP? The key word we're looking for here is included. So if you don't know, draw yourself a picture. You have a triangle, MPX. We're talking about side PM and side XP. Which angle is between them is what they're saying. That would be angle P. So the answer would be letter A. Question 2. Here is the picture. It says which additional congruent corresponding parts are needed to prove the triangle on the left is congruent to the triangle on the right by side angle side. Well, let's look at what we have. We have a side, we have an angle, we need another side. So answers A and B you can eliminate automatically. Side angles side, so we need NP being congruent to EQ. Answer choice D is correct. Last but not least, if triangle NOT is congruent to triangle DAB, which of the following is not true? Well, I would draw myself two triangles. I got NOT being congruent to triangle DAB. Let's go through the answers. First one you find that's not is the correct one. We got OTN. So angle T has to be congruent to angle B. T is congruent to B. Second one, angle N is congruent to B. N is not congruent to B. So there is the one. In an angle, all you have to look for is the vertex angle, which is the middle angle of them. In a segment, it doesn't matter if you name it as NO or ON because it's the same length either way. But an angle, the vertex angle, is the most important angle. So there's the multiple choice questions. Now for the proofs. Question 4. You see a circle, you see a line going through it, you see a triangle being created of ABD, and then there's a line BC in between, breaking up into two smaller triangles. So our given information is circle B, and that C is the midpoint of AD. Well, circle B, anytime you have circle B, you have to think of the idea of all radii are congruent. So AB and BD are congruent because those are the radii from the picture. C being the midpoint of AD, you know that C is right in the middle of AD, causing AC and CD to be congruent. And then BC is reflexive, causing the triangle ABC and the triangle DBC to be congruent by side, side, side. So circle B, reason 1, gave us AB being congruent to BD. From C is the midpoint of AD. We receive AC being congruent to CD. And from the diagram, reason 3, we got BC being congruent to BC. These three statements, we prove the triangles ABC being congruent to triangle DBC. Now we want 3 and 4 to be congruent. That's what we're trying to prove. Well, 3 and 4 are not in our triangle, so we can't just get those by CPCTC. But looking at the picture, we can get angles 1 and angle 2 congruent because those are the two that are inside there. CPCTC stands for corresponding parts of congruent triangles are congruent. So you need corresponding parts. 1 and 2 are corresponding parts to those triangles. When you look at the picture, since 1 and 3 are right next to each other, meaning they're adjacent, and they're forming a straight, you know that 1 and 3 are supplementary. Same thing for 2 and 4. Well, if they're supplementary, and these two are supplementary, and 1 and 2 are congruent, the other pieces also have to be congruent. So underneath here, we can say from the diagram, reason 6, angles 1 and 3 are sup. From the diagram, reason 6, we can say angles 2 and 4 are sup. These three together, reason 7, we have angles 3 and 4 are now congruent. We have 7 reasons. Reason 1 is all radii congruent. 2, definition of midpoint. Reason 3, we have reflexive. Reason 4, side, side, side. 5, CPCTC. 6 was if two adjacent angles form straight, then supplementary. And 7 was supplements of congruent angles are congruent. There is question number 4, which is probably the most challenging one of the 3. Question 5, I would say, would be the easiest. We have QE bisecting RT. QE is bisecting RT, causing RN and NT to be congruent. N is the midpoint of QE, so N is in the middle of Q and E, causing these two to be congruent. And we're done with our givens, but we notice that 1 and 2 are across from each other, so they're vertical angles, which now proves the triangle RQN being congruent to TEN by side angle side. So we got QE bisects RT, arrow out. Reason 1, we got RN being congruent to NT. The angle comes from the diagram. Reason 2, angle 1 is congruent to angle 2 because vertical angles. And then we have N is the midpoint of QE. Reason 3, we have QN being congruent to NE. These 3 together, I'm up to reason 4. We just proved triangle NRQ being congruent to, if I said R, you would tell me TNE. And then we can finish this one up because these are both pieces. RQ and ET are pieces to the triangles we just proved by CPCTC. Reason 1 was def of segment bisector. 2, vertical angles are congruent. 3, def of midpoint. 4, side angle side. And 5, CPCTC. Nicely done. Number 6, the last one here. We have CE being perpendicular to AE, causing a right angle at E. We have BF and FD being a right angle at F. Angle 1 and 2 are congruent. And then EG and GF are congruent, and GC and BG are congruent. Our goal is to prove the triangle ABE, so this triangle here, being congruent to the triangle BFD that I highlighted for you. Well, we noticed that these 2 angles are congruent, E and F, because all right angles are congruent. Angle 1 is congruent to 2, so we have 2 angles, so the only possibility is angle side angle. And then the side comes in between EC and FB, but we're not given those. But if we add these 2 statements together, we can get the bigger statement that we need. So we have CE is perpendicular to AE, which gives me a right angle at E. We had BF being congruent or perpendicular to DF, arrow out, 1 right angle at F. These 2 together give me that angle E is congruent to angle F, which is our second reason, and that's all right angles are congruent. The side came from EG being congruent to GF, and we're adding CG being congruent to BG. Those two together, reason 3, we got EC being congruent to BF. And the last angle was angle 1 congruent to angle 2. These three together, up to reason 4, triangle AEC being congruent to triangle DFB. We have 4 reasons. Angle 1 is def of perpendicular. 2, all right angles congruent. 3, we did addition. And 4 was angle, side angle. If you can master all 3 of these proofs and the 3 multiple choice questions, you will do fine on the quiz 3.1 to 3.3. Good luck to you, and good luck studying.